All right, next video. You guys have the ability to pause, so I'm going to go a little bit fast and furious here. Not to make any Vin Diesel jokes, but yeah, maybe do you have the ability to fast forward as well too? Might want to skip some of these intros until the writing happens. Okay, bonus solves, trig identities. Here we go. We got to solve this identity. Well, it's not an identity. It's solve an equation. That means find the values of x that set this equal to 0. Could use a graphing calculator, but why? So instead what I'm going to do is I'm going to solve this thing by applying identities. Now, I recognize immediately sine 2x is a double angle identity. So this is going to be 2 sine x. My double angle identity is sine 2x equals 2 sine x cosine x. How do I know that quickly? I've just used it probably about 1,000 times. Now, I notice that I have a 2 sine x common to both. Factoring is a religion. We common factor first. So this is 1 minus plus cosine x equals 0. Now that I've factored, I have 2 possible solutions. I have 2 sine x equals 0, or, here's that color I like, or I have 1 plus cosine x equals 0. Now, if 2 sine x equals 0, then that means that sine x equals 0. And that means that x is equal to multiples of pi. So, because we've got our unit circle again, 0 is down here, so that's 0. And then we also have a sine of 0 on the x-axis, and it just keeps alternating back and forth. So 0 pi, 2 pi, 3 pi, negative pi, negative 4 pi. So we have x equals k pi, where k is an element of the integers. That's one set of solutions. But we also have solutions from this one. This tells me that x is a solution when cosine of x equals -1. Now, cosine of x equals -1. Now, where does cosine equal -1? Well, that equals -1 over here. So that means that x is equal to pi. Because if I go pi, I get to -1. If I go negative pi, I also get to -1. And if I go 5 pi, I get to, sorry, I went way too far. 5 pi, I get to -1 as well. But notice that's included in this set of solutions here. So this set of solutions is identical to this set of solutions. Sort of. Because over here, we would have cosine equals 1. So this is actually x equals pi plus 2k pi, where k is an element of the integers. Now, this entire set is contained within this set. This is counting up by ones. This is counting up by odd numbers. When you count up by ones, you hit every odd number. So we don't even need to include that. This is our set of solutions for this problem. Moving on to the next one. Maybe you'd want to use a graphing calculator to solve this. I don't know. But we got to solve this entire thing, and maybe let's see if we can solve it by hand. Okay, I see a lot of terms. When I see a lot of terms, one of the things that I like to do is look for identities that allow me to simplify stuff very, very, very quickly. The other thing I see that I have a 2x inside an argument rather than just x's. Because I have mostly just x's in my arguments, and then this weird 2x, I'm going to use the double angle identity to reduce this one. So, sine x plus cosine x, if it's squared, is 1. So the right-hand side becomes 2 cosine x plus 1 because of the Pythagorean identity. So then this is 2 times sine of 2x is 2 sine x cosine x plus 2 sine x. All right, fun. So I'll multiply 4 sine x cosine x plus 2 sine x. I'm just going to move everything to one side. So I'll subtract 2 cosine x from both sides, and I'll subtract 1 from both sides. And I'm really not happy with myself right now because I'd have loved these equal signs to remain stacked. But I can only be so lucky. Now, wait a second. 4 terms. 4 terms. 4 terms. 4 terms isn't a trinomial. It's not a common factoring situation. Factor by grouping. I'm going to group a couple of terms, and I can group them in any way that I want. but I noticed that I have a sign here and a sign here. So I think that's probably a good way to go ahead and group these. So I'm going to factor out 2 sine x from the first 2. And from the second 2, I'm going to factor out just a negative sign, so minus 1. Now let's see what happens when I factor out that negative 1 from the second 2 terms. I'm left with cosine x, there's 2 of them, plus 1. Okay, now let's see what happens when I factor out 2 sine x from that. Well, 4, 2, 2, sine x gone, cosine x, and 2 sine x, 1. Would you look at that? Those are the same terms. So that means I can factor in pairs again. 2 cosine x plus 1. And what do I have remaining from the first term? Just that 2 sine x. And what do I have remaining from the second term? Just that minus 1. And so I now have a factored set of solutions. Well, I don't have my solutions yet, but I do know that each of these things leads to a solution. So this means that sine x equals 1/2. Remember, I just changed the sign and divide. So this one means that cosine x equals negative 1/2. Cosine x of negative 1/2, eh? Going to my unit circle. A cosine of negative 1/2. Well, cosine's positive here and here, so it's going to be negative here and here. So it's going to be that one, 2 pi by 3, or it's going to be that one, 4 pi by 3. So I've got 2 possible solutions from this. X equals 2 pi by 3 or 4 pi by 3. Now what about from this one? Sine of x equals 1/2. Well, the sine is the vertical part and sine is positive here and here. So that means 1, 2, root 3 pi by 6. And over on this side, it'll be that related angle 5 pi by 6. So I have 2 solutions from this. X equals pi by 6 or 5 pi by 6. And I've just found all of my solutions. Now, if I can do that in less than 7 minutes, I'm pretty pumped with myself. But, darn it, it took me 7.5 minutes. But wait, I did 2 questions, so I did that in less than 7 minutes. Fun. You can verify either of these solutions on a graphing calculator. Now, I will note that I did not do generalized solutions for the second one. Pi by 6 repeats every 2 pi. 5 pi by 6 repeats every 2 pi. 2 pi by 3 repeats every 2 pi, and 4 pi by 3 repeats every 2 pi. So it's all of these solutions plus k pi, or k2 pi, or 2k pi, where k is an element of the integers. Hope this video helped.